Hello. Today we talk about how to find the equation of a line. So it says our goals would be to find the equation of a line using slope-intercept, point-slope, or standard forms. We'll explain what those are, and also be able to find the equation of horizontal and vertical lines. So before, or in a previous video, we learned how to find the slope of a line. Now, the first thing we'll talk about here then is what's called the slope-intercept form of a line, which is the most useful form of a line. Okay. So that looks like y equals mx plus b. Okay. Where if we just do a really basic graph, as it says over here, what this is, imagine these are x and y axes. Let's just have some line that looks like this. This is our line. So the b is the y coordinate of our y-intercept. And m, remember, is what we call slope. Remember the idea of the slope. Think about some point on this line. Any 2 points on the line. And imagine this triangle we form. Remember, slope is rise over run. This is your, this is your run, the bottom. And this is your rise. So the slope-intercept form is the most useful form because we have within it, we can find, pick right out, we have equation in this form. Then this m, this coefficient in front of the x, is your slope. And then the number by itself is the y-coordinate of the y-intercept. There are other forms of lines. Once again, this is the most useful. And also from this form, as we saw in a previous video, we can actually use the slope and a point on the line to graph the line. Now, if you want to find the equation of a line in this form, there are basically 3 cases we have. And those 3 cases are, if you're given the slope and the y-intercept, that's the easiest case, because we can just plug everything in. If you're given a slope and a point on the line, and then if you're given 2 points on the line. So we'll discuss each one of those. So the first one, we'll talk about the easiest case. We've given the slope and the y-intercept. So for these examples, we want to find the equation of the line. Okay. First, number 1, we know the slope, which we call m. In this case, m is going to be 2. And our y-intercept, I'll just abbreviate that, is -3. Okay. And here, when you see it just says y-intercept, that means that's the y-coordinate, because in the x-coordinate isn't stated, there's always going to be 0 for the y-intercept. And so here, we simply plug these in. Okay, so m is 2, then b is equal to -3. So we're going to plug these into y equals mx plus b. And if we do that, that's going to give us the equation of our line, y equals m, which is 2 times x, then plus b, which is a -3, so 2x minus 3. So that is the graph, that's the equation of that line with these, and that's with these 2 features. So having y-intercept of -3 and also a slope of 2. And that's the only graph, that's the only line that fits those 2 characteristics. So that's the simplest case. When you're given the slope and a point on the line, just plug those in. So that's the first case. We know the slope of the point on the line. Our next case then, next example, number 2, we'll look at the case where you know the slope and a point on the line. Okay. So in this case, we know the slope m is equal to, let's say, -4/3, and then a point on the line. Let's write it down here. A point on the line is going to be 1,5. And you say it's a point on the line, or say it goes, the line goes through that point. Okay. Now, here in this case, as it says, we know m, we don't know b. Okay. So you plug m We plug in m in the point and solve for b. Okay, so here in the previous example, remember we knew this, we were able to plug it in right away using both the slope and we knew what b was. B is the y-coordinate of the y-intercept. In this case, we don't know that. Okay, so if you look at our slope-intercept form for y equals mx plus b, we know m, we don't know b, so we need to find b. Okay, so as this says, we're going to plug in what we know, m, which is equal to -4/3, and our point, which is 1, 5. We plug all of these in to our equation for the slope of the line. If we do that, what we get is y is equal to 5 is equal to m, which is -4/3. And then x, which is x, is 1. Okay, plus b. Now we have an equation for b, where only an unknown is b. We can solve for that. Now we need to do a little work first. So let's multiply, of course, -4/3 times 1 is simply -4/3. This is -4/3 plus b. Now here to solve this, we have a couple options. We could add this both sides and then combine fractions. It's probably easier to get rid of our denominator by multiplying through by our least common denominator, which is 3. Okay, so our LCD, our least common denominator, is 3. That's our only denominator. Multiply both sides by 3. So 3 times 5 is equal to 3 times -4/3 plus b. Here, 3 times 5 is 15. Here, distribute the 3. So we have 3 times -4/3. Then plus 3 times b, or just 3b. And then we have 15 is equal to, here, the 3's cancel out. You think this is 3/1. So that's going to be -4 plus 3b. Now we have an equation just for b with no denominators. So we solve this, add 4 to both sides. So 4 plus 15 is 19 is equal to 3b. And then divide both sides by 3. b is equal to 19/3. We can't simplify that. So the equation of our line is y is equal to -4/3 x plus 19/3. That's the equation of our line. So that was the second case, where in this case you're given a slope and a point on the line. So plug both of those in to the point slope form. Then you get an equation where the only unknown is b, then solve for b. Okay, number 3, we do the final case. The final case is we're given 2 points on a line. Okay, so in this case, we find the slope m using the 2 points, then use either point to find b. Okay, so here we have 2 points on the line. And let's say, for example, our 2 points are 2, 3, and -5, 7. Okay, so in this case, for our slope-intercept form, y equals mx plus b. In this case, we don't know either m or b. Okay, so the best way to do this is, if I know what m is, I can do it just like the second example, the one I just did. So first, let's find m. So first, find m, the slope. Remember, m, our formula we saw in a previous video, the formula of the slope is y2 minus y1 over x2 minus x1. Okay, and it doesn't matter which one I call which, just be consistent. So I start with this y here. This y, they have to do, if I do 7, this y minus this y, 7 minus 3, they have to start with this x, 5, -5, minus this x, which is 2. Right, then I simplify this. 7 minus 3 is 4 over -7, and then we just bring the negative up front. So our slope is -4/7. Okay. So we have so far, so now what we have is y is equal to -4/7 x plus b. We now know what m is. And so now we're back to the situation we were a moment ago where you just need to find b. Okay. So we're going to plug in our slope, m equals -4/7 and either point. Okay. We can use either point because both points go through the line, or the line goes through both points. So you can pick whichever one you want to use. That's always up to you. Okay. So I'll just use the first one, though I'm not sure which one is going to be easier necessarily. I'll just use 2, 3. So we do that, we plug all those in. So y is equal to 3. And then is equal to -4/7 times x, which is 2. Then plus b. Okay. Here, let's simplify this a bit. So think of this as 2 over 1. So we have 3 is equal to -4 times 2 is -8/7 plus b. Okay. Now we have a similar equation like we did a moment ago, where you can add this term to both sides and simplify it over here, or you can actually multiply by the LCD, and I think that's an easier way to go. So our LCD, or least common denominator, is 7. Multiply both sides by 7. This works just like the last one. You draw a better B. Okay, 7 times 3 is 21. Here, distribute the 7, so we're going to have 7 times -8/7, then plus 7 times B. And if I simplify my right side, 21 is equal to these 7 things, this multiplying or canceling out. These cancel out. We're left with -8 over 1, or -8 plus 7b. At this step, if you've done this, you shouldn't have any more denominators. If you do, then something's wrong. Here, add 8 to both sides. 21 plus 8 is 29, is equal to 7b. Divide both sides by 7. B then is equal to 29 over 7. Once again, that doesn't reduce. So my equation is y is equal to our slope, which was, once again, -4 over 7 times x, then plus b, and b is 29 over 7. So those are our 3 cases. So easiest case, you know both the slope and the y-intercept, you plug those in. You know the slope and a point on the line, plug in the slope and the point on the line to find b. Then, if you just know 2 points on the line, first find the slope of the 2 points. Then it reverts back to essentially what we did in part 2, where you plug in, pick either point you want, they're both on the line, and plug in the slope you just found and find b. So now the next concept I want to talk about is another form of the line, another equation of the line, called the point slope form. Okay, the point slope form of a line. This is just another form of a line. And as it says, we can use the point slope form where what we have is, looks like this, y minus y1 is equal to m times x minus x1, okay, for a line that goes through, I always write this as through, the point x1, y1 with a slope of m, okay? Now, this is also a form of line, but actually we can show that we can actually go from this form back to the slope-intercept form, okay? So now let's do a quick example of this, okay? So I'll just say convert to slope-intercept form. So let's use the point we used above. So go back to our number 2. Where was that? Okay. Number 2, we know this point, so the slope -4/3, and this point on the line, 1, 5. So let's show that we get the same thing. Okay, here, the equation of our line looked like this. Let's show that we get that. Okay, so for our example here, okay, so 4 have a slope of -4/3. And then the line that goes through the point 1, 5. Okay. So now our point slope form, let's plug these in. And then what we get is, can we see it either up here or over here, y minus the y coordinate, y1, which is 5. And also be careful with your signs here. We're subtracting a positive, is equal to our slope, which is -4/3, times x minus x1, or x coordinate, which is 1. That's the point slope form. Okay, so in terms of point slope form, we're actually done. Okay, what we do here now is then convert this to the slope intercept form. Okay, how we do that then is we solve for y. Okay, so think of this like an equation, because it is an equation. So first, let's distribute the -4/3. And so if I do that first, I have y minus 5 is equal to -4/3 x times -4/3 times -1 is plus 4/3. Okay, so we distributed the -4/3. Okay, now let's add 5 to both sides. So I have y is equal to -4/3 x. Now we have a work we need to do. So we have 4/3 plus 5. Okay, now we don't want to leave it like this. We want to combine these. We want to simplify. Because what if this number here is going to be our y-intercept, and we already know what that should be. Okay, so remember 5, we can write 5 in terms of thirds. Oops, I need a plus right there, sorry. Plus, then we have 4/3. Now 5, the way to do that, remember, is to multiply, this is 5 over 1. I want a denominator of 3, so multiply the top and bottom by 3. And remember, that doesn't change it, that just allows me to write it in a different form. Will match this so I can combine them. So y is equal to -4/3 x plus, we still have the 4/3 here, positive 4/3, and plus 5 times 3, of course, is 15. 1 times 3 is 3. And now if I combine those, now they have the same denominator, I can add those. That's going to be plus 19/3. Now, if we go back and check, is that the same thing we got before for number 2? Should be. Yeah. So -4/3 x plus 19/3. That's exactly the same thing I get here. -4/3 x plus 19/3. So that's a point slope form. So that's also another way you can, another form of the line, but it's also, you can also convert it to slope intercept form. Okay, and once again, I said this is the best form because if I simply gave you this equation, you can pick out right away what the slope is, the number in front of the coefficient in front of the x, including the sign, and then the y-intercept, the y-coordinate of the y-intercept is this, 19/3. Okay, now next let's talk about another form of line you'll sometimes see called the standard form. Now, in terms of graphing, especially on a graph, this is kind of the least useful form of a line, okay? Because we can't pick out the slope or the y-intercept in the form of it. So it looks like this, ax plus by is equal to c, where a, B, and C are constants. Now, why is this useful? Well, sometimes we may need to, sometimes this form is useful when we have systems equations. So if we have more than one equation we're trying to solve. Okay. So let's look at this both ways. So actually, we can, if we want, let's take the former line. Okay. Let's write the one we just got done with, y equals negative 4/3 x plus 19/3 in standard form. Okay, so we can convert it to that. So we're starting with this. Now here, it's okay if we have something in front of our y. So the best thing to do here is once we have a least common denominator of 3, our LCD is 3, let's multiply both sides by 3. If we do that, we have 3 times y is equal to 3 times the right-hand side, negative 4/3 x plus 19/3. Okay, this gives us in 3y. Distribute the 3, we have 3 times negative 4/3 x plus, it's a plus, so we have 3 times 19/3. And once again, after this step, we should have no more denominators. 3 cancels out here and also here. And so we're left with 3y is equal to negative 4x plus 19. And then we have one more step. We want to get the x and y terms on the same side. Okay. So I'll say that. So get x and y terms on the left. And so if we do that, let's add 4x to both sides. Cancels out here. We're left with 4x plus 3y is equal to 19. Okay. So this is just another form of this line. So actually, now we've seen 3 forms of this line. First, we saw this line in point slope form. Next, we converted it to slope intercept form. And now we converted it to standard form. Okay, those are all equivalent, all legitimate forms of lines, and all can be used in different ways. Now, let's do one more version of this. Let's actually start with another line. Let's do an example where we want to write in slope intercept form. Okay, so let's go back the other way. So let's do an example of, let's see if I make up one. Let's do (4x plus 2y). I should make it 4x minus 2y. How about that? Just a change. 4x minus 2y is equal to 8. Okay. Now, here, to do this, we solve for y. Okay, so first subtract 4x both sides. Okay, that cancels out. We have negative 2y is equal to negative 4x plus 8. Okay, now to get y by itself, divide everything both sides by negative 2. Negative 2 is canceled out here. We have y is equal to, now here, we want to separate these because we don't want to leave it like this because we want to put it in slope intercept form. So now think of this, since this is over a common denominator, I can split this up with both over the same denominator. So I have negative 4x over negative 2, and then plus 8 over negative 2. Simplify this, and so that's going to be y, and this is going to be, of course, negative divided by negative is positive. And we're going to have 4 over 2, which is going to be 2, so it's going to be 2x. And here, then 8 over negative 2 is negative 4, so this would be negative 4. So this line, written this way, is exactly the same as this line in slope-intercept form, y equals 2x minus 4. So that was the standard form of a line. Then the last topic to discuss for this video is going to be horizontal and vertical lines, or the equations of horizontal and vertical lines. Now, in a previous video, we discussed, the slopes of horizontal and vertical lines. Remember, a horizontal line is a slope of 0. It actually says that's horizontal line has the equation y equals b, where b is some constant, and b specifically is the b is the y-coordinate of the y-intercept. Okay, then a vertical line has the equation x equals a number, where the x-intercept, the x-intercept where the graph crosses the x-axis looks like this, where that is a0, so that's the x-coordinate of the x-intercept. It has an undefined slope. So to practice with this, let's find the equation of the horizontal, I'll just abbreviate that, and vertical lines. Abbreviate that, lines that go through the point. How about we just do 2, 3? Okay, so let me paste a axis on here with the graph. Hopefully it's still there. Good. I'm actually enlarge that some. Actually, let me move it down a bit so we can. Okay, now first let's find this point. So 2, 3. So go over 2, up 3. So the point 2, 3 is right here. Now, the horizontal line that goes through 2, 3 looks like this. And the vertical line that goes through 2, 3, of course, looks like this. Okay, so look back at our directions here. What it tells us is that horizontal line has the equation x equals b, where b is the y-intercept, is the y-coordinate of the y-intercept, and that then would be the point 0, 3. Okay, it's also going to go through 0, 3 as a slope of 0, remember, for a horizontal line. Okay, and so actually back up just a bit. So here, b is equal to 3. Okay, and actually, if you notice here, our equation abbreviate that is y is equal to 3, because if you notice on our line, y is always 3. No matter what x is, y is always 3. It does depend on x. Okay, now a similar way, our vertical line. Okay, find out what a is. So a is the x-coordinate of the x-intercept, where it crosses the x-axis is here at 2, 2, 0. Okay, so our a there over here is equal to 2. So then the equation of that vertical line is x equals 2. In a similar way, x is always 2. No matter what y is, x is always 2. It doesn't depend on x. So this line has the equation x equals 2. This line has the equation y equals 3. Okay, so now to summarize what we've done so far today. So we saw how we can find the equation of a line given the slope, given things about the line. So the 3 cases, given the slope and the y-intercept, slope and a point on the line, or 2 points on the line. We also talked about the point slope form and the standard forms, how to convert between those forms and the slope intercept form. And also showed how we get the equations, horizontal and vertical lines. All right. Thank you. Have a good day.